The invention of the television was the work of many individuals in the late 19th century and early 20th century. Individuals and corporations competed in various parts of the world to deliver a device that superseded previous technology. Many were compelled to capitalize on the invention and make profit, while some wanted to change the world through visual and audio communication technology. Mechanical television. Facsimile transmission systems for still photographs pioneered methods of mechanical scanning of images in the early 19th century. Alexander Bain introduced the facsimile machine between 1843 to 1846. Frederick Bakewell demonstrated a working laboratory version in 1851. The first practical facsimile system, working on telegraph lines, was developed and put into service by Giovanni Caselli from 1856 onward. Willoughby Smith discovered the photoconductivity of the element selenium in 1873. As a 23-year-old German university student, Paul Julius Gottlieb Nipkow proposed and patented the Nipkow disk in 1884. This was a spinning disk with a spiral pattern of holes in it, so each hole scanned a line of the image. Although he never built a working model of the system, variations of Nipkow's spinning disk image rasterizer became exceedingly common. Konstantin Persky had coined the word television in a paper read to the International Electricity Congress at the International World Fair in Paris, on August 25, 1900. Persky's paper reviewed the existing electromechanical technologies, mentioning the work of Nipkow and others. However, it was not until 1907 that developments in amplification tube technology, by Leda Forrest and Arthur Korn among others, made the design practical. The first demonstration of the instantaneous transmission of images was by Georges Reynaud and A. Fournier in Paris in 1909. A matrix of 64 selenium cells, individually wired to a mechanical commutator, served as an electronic retina. In the receiver, a type of Kerr cell modulated the light, and a series of variously angled mirrors attached to the edge of a rotating disc scanned the modulated beam onto the display screen. A separate circuit regulated synchronization. The 8-byte pixel resolution in this proof-of-concept demonstration was just sufficient to clearly transmit individual letters of the alphabet. An updated image was transmitted several times each second. In 1911, Boris Rosing and his student Vladimir Zworykin created a system that used a mechanical mirror drum scanner to transmit, in Zworykin's words, very crude images over wires to the brown tube in the receiver. Moving images were not possible because, in the scanner, the sensitivity was not enough and the selenium cell was very laggy. By the 1920s, when amplification made television practical, Scottish inventor John Logie Baird employed the Nipkow disk in his prototype video systems. He created his prototype in a little village called Santa Cruz on the island of Trinidad, where he was recovering from an illness. He had also started work on the first color television. On March 25, 1925, Baird gave the first public demonstration of televised silhouette images in motion, at Selfridge's department store in London. Since human faces had inadequate contrast to show up on his primitive system, he televised a ventriloquist dummy named Stucky Bill, talking and moving, whose painted face had higher contrast. By January 26, 1926, he demonstrated the transmission of an image of a face in motion by radio. This is widely regarded as the first television demonstration in history. The subject was Baird's business partner Daisy Elizabeth Gandy. Baird's system used the Nipkow disk for both scanning the image and displaying it. A bright light shining through a spinning Nipkow disk set with lenses projected a bright spot of light which swept across the subject. Selenium photoelectric tube detected the light reflected from the subject and converted it into a proportional electrical signal. This was transmitted by AM radio waves to a receiver unit. where the video signal was applied to a neon light behind a second Nipkoff disc rotating synchronized with the first. The brightness of the neon lamp was varied in proportion to the brightness of each spot on the image. As each hole in the disc passed by one scan line of the image was reproduced. Baird's disc had 30 holes, producing an image with only 30 scan lines, just enough to recognize a human face. In 1927, Baird transmitted a signal over 438 miles of telephone line between London and Glasgow. In 1929, he became involved in the first experimental mechanical television service in Germany. In November of the same year, Baird and Bernard Nathan of Pathé established France's first television company, Télévision Baird Nathan. In 1931, he made the first outdoor remote broadcast of the Epsom Derby. In 1932, he demonstrated ultra-shortwave television. Baird's mechanical system reached a peak of 240 lines of resolution on BBC television broadcasts in 1936, though the mechanical system did not scan the televised scene directly. Instead, a 17.5 mm film was shot, rapidly developed and then scanned while the film was still wet. An American inventor, Charles Francis Jenkins, also pioneered the television. He published an article on motion pictures by wireless in 1913, but it was not until 1923 that he transmitted moving silhouette images for witnesses, and it was on June 13, 1925 that he publicly demonstrated the synchronized transmission of silhouette pictures. In 1925, Jenkins used Nipkoff disc and transmitted the silhouette image of a toy windmill in motion over a distance of 5 miles from a naval radio station in Maryland to his laboratory in Washington, D.C. Using a lens disc scanner with a 48-line resolution, he was granted the U.S. Patent No. 1,544,156 on June 30, 1925. Herbert E. Ives and Frank Gray of Bell Telephone Laboratories gave a dramatic demonstration of mechanical television on April 7, 1927. The reflected light television system included both small and large viewing screens. The small receiver had a 2-inch wide by 2.5-inch high screen. The large receiver had a screen 24 inches wide by 30 inches high. Both sets were capable of reproducing reasonably accurate, monochromatic moving images. Along with the pictures, the sets also received synchronized sound. The system transmitted images over two paths. First, a copper wire link from Washington to New York City, then a radio link from Whippany, New Jersey. Comparing the two transmission methods, viewers noted no difference in quality. Subjects of the telecast included Secretary of Commerce Herbert Hoover. A flying spot scanner beam illuminated these subjects. The scanner that produced the beam had a 50-aperture disc. The disc revolved at a rate of 18 frames per second, capturing one frame about every 56 milliseconds. Television historian Albert Abramson underscored the significance of the Bell Labs demonstration. It was in fact the best demonstration of the mechanical television system ever made to this time. It would be several years before any other system could even begin to compare with it in picture quality. In 1928, WRGB, then W2XB, was started as world's first television station. It broadcast from the General Electric facility in Schenectady, New York. It was popularly known as WGY television. Meanwhile, in the Soviet Union, Elia Kuto-Nemin had been developing a mirror drum-based television, starting with 16 lines resolution in 1925, then 32 lines and eventually 64 using interlacing in 1926, and as part of his thesis on May 7, 1926, he electrically transmitted and then projected near-simultaneous moving images on a 5-foot square screen. By 1927 he achieved an image of 100 lines, a resolution that was not surpassed until 1931 by RCA, with 120 lines. On December 25, 1925, Kenjiro Takayanagi demonstrated a television system with a 40-line resolution that employed a Nipkoff disc scanner and caught to display at Hamamatsu Industrial High School in Japan. This prototype is still on display at the Takayanagi Memorial Museum in Shizuoka University, Hamamatsu campus. His research in creating a production model was halted by the US after Japan lost World War II. Because only a limited number of holes could be made in the discs, and discs beyond a certain diameter became impractical. Image resolution on mechanical television broadcasts was relatively low, ranging from about 30 lines up to about 120. Nevertheless, the image quality of 30-line transmissions steadily improved with technical advances, and by 1933 the UK broadcasts using the Baird system were remarkably clear. A few systems ranging into the 200-line region also went on the air. Two of these were the 180-line system that Compagnie des Compteurs installed in Paris in 1935, and the 180-line system that Peck Television Corp. started in 1935 at station VE9AK in Montreal. The advancement of all electronic television marked the beginning of the end for mechanical systems as the dominant form of television. Mechanical TV usually only produced small images. It was the main type of TV until the 1930s. The last mechanical television broadcasts ended in 1939 at stations run by a handful of public universities in the United States.